Well, why don't we get started? Good afternoon and good morning and good evening, depending on where you are across North America and beyond. My name is Frank Sullivan. I'm the Chief Business Development Officer at BrainBox AI, and I'm really delighted to be along with my distinguished panelists today that I will introduce in a moment, and most importantly, excited to be a part of this important energy challenge. Just a moment on us. BrainBox AI is a software firm based in Montreal, Canada, with offices in the United States, and we utilize self-adapting artificial intelligence technology to proactively optimize the energy consumption of one of the largest climate change contributors out there, and that's buildings. And we've been an important and excited participant as a part of this process. I'd like to introduce my panelists very quickly. John Eubank, who's the Director of Artificial Intelligence for Alion, and they provide customized solutions for the federal government data processing challenges in ISR, AW, 5G, space, and cyber. Ken Morris, founder and CEO of Kinetic IQ. And Kinetic IQ harnesses the power of zero trust to deliver ultra security and data agility to a world inherent with digital risk and attack. And finally, Colin Gowden, CEO at VIA. And VIA's TAC software platform securely connects power data to AI solutions distributed across governments, regulators, power providers, and they serve more than 100 million customers globally. So really, to set the context, and what we hope to do over the next just under half an hour is to engage the panelists in a dialogue. And I've prepared with their assistance a series of questions that are hopefully thought-provoking, but really underscore why is a panel on energy data so important. And as we got together just a couple of days ago in order to frame some of our comments, our vision statement above all is this: the DoD is a data-centric organization that uses data at speed and scale for operational advantage and increased efficiency. And within that context, I'd like to challenge each of the panelists to work through a couple of questions, and hopefully we'll have a spirited dialogue. And so, John, if you don't mind, I'll start with you. In the context of a data-centric organization, one that is so large and far-reaching as the DoD, what are the pillars of organizing energy data that should fundamentally frame the solution discovery that's at the heart of the challenge here today?
Yeah, so echoing that vision statement that you started with, coming out of the DoD data strategy, having worked for the last decade in the data science community, exploring the DoD's data challenges, the pillar is really how do we make the data usable and accessible while still maintaining the security of that data. As we look at the raw sensor feed, the data streaming across the networks, the policy content, the education, the training content that's informing energy culture, the future of our DoD, how do we label it? How do we tag it? How do we generate the metadata that content can be usable in the future? Then the provenance, the lineage of the data. Where did it originate? Can we trust that data? Is the supply chain providing us the data reliable and something that we can trust for our decision-making with the warfighter? But what's the retention that we need to apply to the data? Is it data we're going to use once and maybe we're adjusting the thermostat in a building and we don't really care what the temperature was when a user adjusted the thermostat? Or maybe we want to look across the force and see changes in thermostats over time. So how do we retain that data? How do we prioritize it while still operating inside budgetary constraints? And then that last pillar, raw versus refined data. So when we transform data, we normalize it, we change it for whatever operational use, is that impacting other analytics that may want to operate on that data, other decision-making tools that we have available to us? So really keeping in mind those trade-offs as we take raw data and we do some kind of translation on it or some kind of normalization of it to a refined data set that we can use.
So John, the provenance is so important, and most importantly, energy data is coming from so many disparate sources, and that really resonated with me in your comments. But Colin, over to you, just to add on top of it. What are those key pillars that are important to you as it relates to organizing energy data, and why is that so important to get the foundation right?
So I'd say a couple things. I think John is spot on there. I actually might not add any new pillars to that. It's a good,
expand,
it's a good list. And I think if I were to, reinforce access is clearly important, right? And as you mentioned, provenance, ingestion, all of those I think are key. And I don't know if I'd add anything to that list. I might say something that, as over the last, I'd say 4 or 5 years that's taken hold is there isn't a need necessarily to have data transfer as one of the pillars, right? So centralization of data used to be, I would say 5-10 years ago, it's like that was one of the pillars. I got to figure out how to aggregate and put it all in one place and make it accessible in one single format for everyone. A lot of new technologies around federated learning and some of the platform work we do around this area of being able to look at data while it's still in different locations and in different formats. That means actually you can remove a pillar or not have to add another pillar, which anytime you can make something, remove something means it's going to be simpler and easier and faster to execute. So maybe just as important is not adding to that, but taking away a pillar, which is you don't have to centralize as much as you used to have to in the old days.
So Colin, are you really suggesting that the efforts that we've all been and the industries have been involved in around centralizing, securing data really flies in the face of what we're trying to achieve by unlocking that pursuit in order to solve these energy challenges that are so important and we're facing at scale?
I think a couple of things. First is, technologies moves pretty fast, right? So Google sort of came up with the term federated learning only about in 2015, 2016. So, what used to be true, right, made good sense. Of course, it's logical to try and put everything in one place and store it and, have it in one format. I think that made perfect sense in a world where there wasn't as much data and when there wasn't really a viable alternative. I don't think that's, as true anymore. There are lots of more viable, alternatives. And so we should just be aware the world has changed, in lots of ways. And, we should be like, this meeting is an example of us doing things differently, which we wouldn't have done a year ago, right? So if the world changes, we need to keep up and with that. And that's just that's sort of the ethos here. I'd say the only other sort of element I'd add is that I think, in addition to sort of, the technologies changing, that as the data volume continues to grow, right? So I think John mentioned, smart devices, right, and IoT. As we go from a meter reading, which might have been once a month, to a smart meter, which is once every 5 minutes, now I've got 8,000 times as much data as I used to, never mind how many new readings I have on that. You can't actually move all the data and centralize it as much as, as you used to. And I think John kind of referenced that too. It's like, what's the signal that you really want? Find that, pay attention to that. Like all this other data, it's like, don't worry about storing, maybe you don't need to store that or centralize that.
It's so true, and we'll discuss that in a few moments. This notion of you can't possibly compile and draw analytics on all of it. The key is finding what's most important, promote that, and take action. Really appreciate your insights, Colin. Ken, last but not least, you weighing in on this. Are there pillars that we've missed, or why is this so important in order to get the foundations right?
I think the foundations that have been laid out by Colin and John are fine and they're accurate. I would just put a slightly different perspective on things. As Colin noted, there's a lot of data that is just being aggregated in federated places around the globe. And so the question becomes, are we adopting a principle of data is available when it needs to be available, to whom it needs to be available, and it's done securely? Now, whether or not that one is processing data in situ in some federated site somewhere, or whether they're moving data to where it needs to be used, the underlying principle is still the same. One of the challenges I think we have is not challenging ourselves to think differently about the process. This is not an either or matter. It's about looking at the principle of we have a warfighter that needs data down at their radio. We have someone who needs data that may be in their particular aircraft. They're on a sortie somewhere. But all of that has to be real-time, unadulterated. It has to be accessible and usable. And so looking at this from a principle standpoint, I think DoD by and large got it right when they're thinking about their new data strategy is we have to have data at scale, at speed, when it needs to be there. Some of the current piping systems in terms of whether it is secure in the sense of being classed or unclassed, I suspect we're going to see some breaking downs of that as we become more data centric in our approach.
John, to follow that on, are they, you know, not only is your firm involved in securitizing this data, whether at rest or in transit, more and more of this information is unstructured and it's coming from so many different sources, as both John and Colin really framed a moment ago. What are the security concerns, Ken, particularly that you want to highlight for the team here that really need to be prioritized in this new environment?
Well, there's a couple of principles here. One is certainly, as we think about the security of data, it's access to the containers, as we call it, not containers in the sense of Kubernetes, but containers of repositories, and also access to networks. And then the security around the data itself in terms of what type of cryptographic controls are we using. There are a couple of underlying principles that we found to be extraordinarily helpful. And that is no cryptographic secret, no credential that one may be using should live beyond, which means before or after its function. So if its function is to provide access, as soon as that access is granted, that particular credential no longer exists. When you're thinking about establishing identity as well, from an access standpoint, that credential should not exist, again, beyond its function when we think about encrypting data. So stored, static keys, credentials, certificates, these are hallmarks of what we all do today, and they're considered best practices. Unfortunately, they provide a bit of threat vectors for our adversaries. And so the question for us becomes, why do we hang on to them longer than they're needed? Particularly when we think about data in transit, we think about C5, so command and control communications, you can just go right down the list. We don't want our adversaries being able to tap information about what are we doing with energy resources. So how much is being used here, fueling there. While they may not attack the line, the fact that they have intel on what's being used, how many gallons of fuel are being shipped here. It provides another piece of the puzzle for them to at least begin to put together what we're doing. So this whole notion of data, when we think about energy, it's far beyond discussions that we may typically have, and it covers the gamut. Data really is driving everything today, and it's not just even around sort of energy as we think about it. It drives our warfighters, it drives decisions that we make. And that data must remain accurate, secure at all times. And the security controls that we have around it themselves should be ephemeral to a degree that doesn't allow an adversary to get into a zero trust environment.
So to your point, no points of weakness anywhere in the supply chain.
Exactly.
Ken, thank you. Colin, from your perspective as well, really narrowing in on, security is a prerequisite. It's clear as harnessing data in order to drive better energy outcomes and to shift resources to enable the warfighter in other areas. What are the 1 to 2 or 3 security concerns from your perspective that really need to be prioritized here?
So I think privacy, data, security and privacy are linked, but not identical. And I think what, Ken's point, I think, is a good one about, making sure that only the people who have credentials get them, and they only keep them for the time they need them, right? So there's a ephemeral basis. I think, Ken, the word you used, sort of ephemeral basis to that. Like, even when someone is authorized to have access to some set of information or to analyze it, I think the next layer, and something we spend time thinking about, is how to manage or control or provide the kinds of questions or at a query level. So, Frank or Ken or John may have access to data, but maybe you're only allowed to ask certain kinds of questions. So to Ken's kind of analogy about energy, you're allowed to ask questions about like what the, how much energy is being used on average or in aggregate, but not about a certain sortie or on this date, how much energy was used at this level. You know, that's more at a permission level. It's not really about you as a user, but about the question or the query level. And we're seeing more and more, that's a level of security that's often, you know, not implemented.
Context-based access, I think is what you're underscoring. Fair?
Yeah, I think that's a good way of putting it. Exactly. Yeah,
Fabulous.
and there's much more now. There's a lot more ability to think about that context level sort of security, which I think is very important, and especially because you don't know until you actually ask the question. You can give somebody access, but you don't know like what they'll do with the data when they have it. They might give it to the next person.
Colin, if I follow that one more step, increasingly the edge, you know, there's always a tendency every new decision of empowering the edge from a compute standpoint, from a security endpoint standpoint, querying the edge and data gathering specifically around energy efficiency is where lots of the data, think of all of the myriad of points from thermostats to BMSs to you know, how much fuel is in a given depot. With that added context, Colin, are there additional foundations that are required to secure and enable the edge for efficient data gathering?
I think so. I think how the aggregation happens. So there are lots of sort of mathematical things that people are kind of, you know, I think Google and Apple are, you know, who all of the devices, which, you know, I guess won't show up on my, you know, blurred image here, right? All of our Samsung or Apple phones all have differential privacy or k-anonymity or some kind of, you know, edge aggregation. And those are basically mathematical guarantees around I'm allowing someone to do some processing or some analysis at the edge, but not enough to actually identify who that is, or, you know, at sort of a row level. And I think that's you know, that all of the, again, all the math and technology is moving pretty fast. And I think it's easy to get trapped into, well, in the old days, like 2 years ago, you know, we used to do it this way, so that's the way we should be doing it today. It's like all that has moved pretty fast, and just making sure, you know, when we're thinking about the edge, are we using not just the latest, but what's actually mathematically proven to be better ways of providing that security.
Colin, thank you. And John, I know you've been patient down there. You're in the bottom of my screen. Security concerns that need to be prioritized from your perspective in the context of the energy challenge. What's top of mind for you?
Yeah, so coming out of the cybersecurity community, and my background involved a lot of time over at NSA in the intelligence community, one of the challenges is actually being too secure with our data. And, you know, inside the DoD, what does that mean? It probably means putting our data on JWICs or on the top secret networks, the special access program networks. And while, yes, we're applying excellent security on those networks and we're restricting the data, it really gets in the way of that DoD data-centric organization vision for operational advantage and increased efficiency. When we inappropriately or missecure our data and put it locked away where it can't be accessed and it can't be operationalized. So looking at, you know, I was on the East Campus planning team, which was building out the new buildings that are going in for US Cybercom and NSA up there, and looking at the substations and looking at the Utah data center. And the energy usage of those systems was actually classified TSSCI. So no one could understand what even the energy consumption, no one in the commercial community or no one in the broader DoD operating on the NIPRNet networks could even understand the value of that data, what's inside of it, how it could inform future decision-making, future build-outs that were occurring. So really looking at what is the appropriate security for this data? Is this data really TSSCI, and is it creating an advantage for our adversary to be processing it on the unclassified network? And if it is, can we still process it on the unclassified network, but can we put the appropriate encryption around that data that it can be aggregated, processed, whether that's processed at the edge, processed back at a central cloud, wherever it may be, to enable that operational advantage and that increased efficiency.
And John, I hear you, you know, and as an organization that relies on customers and organizations giving us data, i.e. energy usage, so that we can help predict more efficient posturing of their energy systems. If that's locked away in a vault, there is an untapped resource that is getting, you know, that isn't being optimized. Ken, I think you'd like to chime in here.
Sure. You know, it's something we talk about here a lot at Connect IQ, and that is data that is not operationalized in a meaningful way, that is not agile, that is not available to where it needs to be, becomes problematic over time. And I think the example that John gave of this, where you've got data locked away, and the question is, how do we handle the varying levels of security? Well, this is where auditable zero trust principles come in handy. As we begin to design and refine our networks and our decision making around who can get access to what becomes a matter of where are you in the trust environment, and probably less a matter of sort of physical piping in ways that we typically see it today, that we're going to restrict this. And now if we have to move it, how do we move it securely? This is where this degree of ephemerality around credentialing and cybersecurity becomes vital, because you only want, for example, a one-time use key. Think about digital one-time pads, most secure that we can think about. And in effect, using that particular principle is what allows this data to be released to where it needs to be released. And oh, by the way, it needs to be auditable and monitored in flight or in transit. So you know that only that individual, that device, they're the only ones that had the capability of generating the key real time in situ in their device to decrypt that payload, key's gone, and you go about your business.
So Ken, methods like that, and Colin, I'll just ask you to comment, methods like that sound so important because there's a natural dichotomy, I'm thinking of another word. These two tendencies are at odds that John illustrated for us. How do we provide the commercial sector, which is at the core of what this energy challenge is all about, with the data that they need to do something about it, while adhering to the intense and critical security requirements at all those levels? Square the equation for me, Colin.
So I think that, again, a few years ago, this is why AI didn't happen, right? Or you couldn't square the equation. And I think actually the good news is technology is moving in the right direction to help, in these areas. I think, John talked about data being, on top secret networks, for example, and therefore inaccessible. There are ways of kind of brokering this where you'd say, look, our goal is to make sure the data remains both in place, right? And we use mathematical means to make sure you aren't accessing that data or transferring it, but you're only getting back data that I can test and see, yes, this is actually making, I can guarantee that this is still anonymous once I have analyzed it. Or, as we get into things like deep learning and AI, those kinds of algorithms tend to be very greedy and they need a lot of data. Actually, there are things like homomorphic encryption, particularly on the addition side, where the data can remain encrypted and you can still analyze it. So you don't have, so even if you did have the data, it's like, I can't read it because it's encrypted, right? But I can learn from it, right, without having to decrypt that data. I think, there are those kinds of tools and techniques.
So you get the taste without the calories.
That's exactly, it's less filling and taste great.
Yeah, funny. We clearly need to get out more. Colin, thank you for that. And you're teeing up really what is our third aspect. And John, I wonder if you could take us home. And I'm just keeping mindful of our time here. We've probably got 5 or 6 minutes together. Colin really spoke to it. So AI, deep learning, there's advancements in tool sets here. And what role do they have, John, from your perspective of creating actionable decision-making for DoD around energy management?
Yeah, great question. So my team, we're working on a product called Fortis AI, working with Amazon, some of the leading natural language processing providers. And what we're really struggling on is you can't just release the AI in the wild, whatever your model is, whatever your analytic is, and expect it to give you back an actionable result. So this need for human AI collaboration, especially prevalent here in the energy community with very disparate data sets. The AI isn't going to match the data together automatically, take raw data and somehow give you out refined data to answer the question you had that the AI didn't even know you wanted to answer. So really, when we look at the decision-making power of artificial intelligence, we're still early in the life cycle here, and there's many years ahead of us where we're going to see some amazing improvement in the power of analytics. GPUs coming to the edge every day now, getting more powerful. It's really changing the dynamic, but it's important to have data scientists paired with those capabilities that can truly say, what does the user community need to get out of the data? What are the models that are available to us? My team's specializing in natural language processing. There is no one-size-fits-all solution. We got to take a variety of solutions, create a plug-and-play environment where we can bring them to the table, and then really work with that user community to make sure we're giving an actionable answer back out to the informing mission, and we're not just spending millions of dollars because we got AI.
You got it. I mean, John, you've really, and Colin, I'll ask you to comment and then finish off with Ken. Our experience around leveraging AI tool sets is about upscaling the operational capability of individuals and teams in the field that used to have low-level tasks. And AI, above all, can present, to your point, more actionable decision-making and can, in many instances, automate those level 1, level 2 type activities. And so that the staff, the experts, can actually focus on much more higher level activities that are fundamentally more impactful. Colin, from your perspective, what's the role that AI and deep learning has to play here?
I think a couple things. I agree. I mean, if you every movie you've ever seen where a computer makes the final decision ends badly, right? There's, the Hollywood, humans need to be in the loop, right, about lots of the decision making and in lots of ways. So totally agree with that. I would say, at the same time, AI, we probably use, every single person on this call uses AI every single day, whether they know it or not, right? Every time you point your camera phone at a person, a little rectangle shows up and says, this is the person's face, right? Whether you're inside or outside in a crowd, it's a stranger, that's all AI that's done those models that are pre-trained. So the AI is getting faster and smarter, at an exponential rate, only though where it has access to the data. And there's a reason why Google and Facebook store all our photos for free, not because they're kind and generous companies, but because they want to store all our photos so they can do these photo training, these image analysis, facial recognition, all of these kinds of algorithms. So if we really want AI to be applied in data, we do have to find ways of allowing it to be analyzable. That doesn't mean transferred somewhere. That doesn't mean free and open. Doesn't mean accessible by everyone. It just means analyzable. And there are lots of mathematical ways to guarantee security, privacy, and make it analyzable. That didn't exist just a few years ago. And so hopefully, that will, embracing that will mean you can embrace AI.
And propagate more fully. Colin, thank you very much. Ken, last words to you. Why is this so important? What's the role that these tool sets can play in a meaningful way for the DoD?
Well, again, if we think about the amazing technologies and the work that's being done here by companies such as Colin and John, and there are others out there as well, they all require data. That's kind of gone without saying. But what we look at is there an enabling environment that is zero trust based that allows all this good work to occur? So whether or not it is data that is being processed in situ and sitting in federated data systems somewhere, access to that should absolutely be known and locked down. No one else, an adversary, should not be able to use valid credentials just to get access. Unfortunately, that's a bit of a problem today. When we also think about moving data, is it being moved securely to the endpoints? Is it coming back and forth? Does the warfighter have it? Do those who need to make decisions, can you trust this data? Do you know the provenance of the endpoints? We're sort of wrapping up with how John kicked us off earlier. All those central points are key, and it boils down literally, bottom line, to do you have a trusted, known, secure environment that is auditable, that you know everything that has occurred, it's logged
throughout the chain,
throughout the entire chain. So the entire life cycle of that data should be known. And right now, we still have a ways to go, but that's the type of technology and solutions that we bring to the table, is to ensure that you know where your data are even though it's 3 a.m. in the morning.
And on that, Ken, thank you. Colin, John, and to all of you out there, thanks for allowing us to not only share together, but also to uncover hopefully what's next and continued good sessions. And we appreciate your time very much. Thank you, gentlemen.
Thanks, Frank.